Okay, so finally, equations might look something like this. In the following examples, if the expression is linear, then the equation is linear. If the expression is quadratic, then the equation is quadratic. So, my turn first. What type of equation is this? It's quadratic. How do I know? Because the expression is quadratic. And so on. There's actually a bit of a choice here about the type of questions that I ask. So, especially as we go across many days here, I asked a correlated feature question there. So I've correlated the feature of having a quadratic expression with the idea that the whole equation is quadratic. At the beginning I said, for the following examples, that was necessary because I needed to communicate that this was true only for the examples I was about to share. As we'll see when we get to the end, it's possible to share examples where A, it doesn't make sense to just talk about, quote, the expression, or B, looking at the expression directly wouldn't actually tell you what type of equation it is. So that's one thing that I've done. I didn't have to include the... Actually, is there a way that I couldn't have included the... I'm thinking, what if I just treated this like a categorical? What if I just said, this is... No, you absolutely need the correlated feature part, the how do you know part, I believe. But it's still relatively covert. The trouble is the possible risk is with the... Okay, so let's say, what type of equation is this? Quadratic. How do I know? Because the expression is quadratic. Well, if you're getting that right, that's fine, but the thinking that's going on in your head as to why you think the expression is quadratic, that is covert. It is hidden from me. And so there is the possibility, maybe, depending on how much testing around expressions, polynomial expressions we've done in the past, there is the possibility that you're getting this right while attending to the wrong thing, or just guessing, maybe. Either way, certainly your thinking at that point is hidden from me. That's okay. Eventually we want these things to be covert. Covert is fast. It tends to be connected with implicit memory. So it's very, very quickly you know what you're looking at. But what about the explicit memory, also called declarative? Explicit memory is needed to actually talk about what makes something linear or quadratic or cubic. And you don't know that they have that unless you test for it. So it could be that we've been testing for, as I suggested, we've been testing on polynomial expressions for a long time now. And so when they say, because the expression is quadratic, that's just sort of taken for granted now that they've learned that completely. But there are other options, and I just want to point out those options. So yeah, I'm just going to go through two of them. One option might be, at the beginning, choosing to ask a number of smaller and each more overt questions. So effectively guiding students through the whole cognitive routine. So it looks something like this. What is the degree of each term in this expression? And I'm looking for 2, 1, 0. Which term has the highest degree? 7x squared. What's the degree of that term? 2. So what is the degree of this polynomial? 2. So what type of expression, what type of polynomial expression is this? Quadratic. So what type of equation is this? Quadratic. So that was 6 questions, which collectively tell me everything about their thinking, guides me through the whole thing. What is the degree of degree of each term, which term has the highest power, sorry, the highest degree, what is the degree of that term, so what is the name of this polynomial, and therefore what is the name of this equation, or what type of equation is it. The alternative is to go the other way. So I could say, what type of equation is this? Quadratic. How do you know? Because the expression is quadratic. How do you know? Because it's of degree 2. How do you know it's of degree 2? Because the term with the highest degree is degree 2. Which term is that? 7x squared, and so on. If you do it that way around, so that time I was going, okay, what type of equation is this? Quadratic. How do you know? Because the expression is quadratic. How do you know? How do you know that I should probably be saying, how do you know the equation is quadratic? Because the expression is quadratic. How do you know the expression is quadratic? Because it's of degree 2. How do you know it's of degree 2? Because the term with the highest degree is of degree 2. Which term is that? 7x squared. That could eventually turn into the question, what type of equation is this? Explain your thinking. Explain your thinking, or justify your response, or something like that. That would actually give us, I mean, this is kind of at the heart of what seems to be on the agenda right now with oracy. Implicit memory is pretty good for feeling like you understand what something is, for being able to identify it very quickly, but it is explicit memory that you have to have, or explicit knowledge, declarative knowledge you have to have if you want to be able to verbally talk about something. And so that set of questions that I just talked through there that were fully overtized, that could eventually turn into this more covertized routine here, but where you're responding with all 6 steps there in order to justify your response or explain your thinking. Okay, talking about explaining thinking, all of this across the videos, this has taken a lot longer to explain than it would actually take to teach in the classroom. That's because I've been going through all of the possible design options throughout, and all of the alternative designs that I think are legitimate that one could select instead. In terms of what it would look like in the classroom, it is a series of what we might call learning episodes, probably just a few minutes, several minutes long each, probably taking place over days, possibly weeks. They could all be done in one lesson, maybe, but then there's a lot of new content if we do that, and not as much opportunity for recapping and distributing practice. So splitting it all up, I think there were 6, 7 or 8 videos or something I've just put together, splitting all that up into things that are being covered across multiple lessons, with some initial instruction, with some retrieval practice of what's come before, etc. That's the kind of thing that's going to guarantee long-term memory retention. And then into the future, once this kind of explicit instruction has been taken care of, we're obviously going to be working with polynomials and different types of equation and such in the future. And so there's plenty of opportunities there to keep asking, okay, what type of polynomial is this? What type of equation is this? How do you know? How do you know that? And so forth. And that would ensure continued ad hoc retrieval practice, making sure that, again, pupils are going to remember the names and where they come from. One final thing, there is a later atom that I think could come through. And that would mean dealing with equations like this one to begin with. So just where it's not set equal to 0. That atom is probably, well, to go back to what I said right at the beginning, the idea of look at the expression is cubic, therefore the equation is cubic, doesn't work anymore, because which expression? We now have two non-zero expressions. So which one do you mean? And there's no reason this couldn't be the other way around. So no guarantees that it's the one on the left. So that atom that I'm talking about is probably to rearrange first and set the equation equal to 0 before deciding the type of equation it is. And one reason that might be an important atom to develop is because if you have an equation like this in particular, well, that looks at first glance like a quadratic, but it is of course a cubic. Okay, that is everything. If I were planning from first principles how to explain to kids what we mean by quadratic equation, this is roughly how I'd go about it. This is it would look something like this. I'd want to teach them to recognize quadratic equations by doing something like all of this first. I'd want to build out the larger set of polynomials, including the names of the different terms, monomial, binomial, when there were different terms, trinomial as well. And then, of course, there's lots of things to learn then about the concept of a quadratic equation, mapping them to the Cartesian plane, the analytic geometry, finding the roots, and so on. But that's it. I hope this has been of some interest or some assistance to somebody out there. If it is, let me know, and I might make more things like this in the future.